Hey, my apologies. We had to. This is a session sponsored by Dell, so we were going to have HostNet actually talk about their network. Unfortunately, the HostNet team couldn't make it for today, but we found a very good topic instead. And some of you I've seen in my session before talking about open networking. So we've invited Bigswitch. Bigswitch, one of our partners on the SDN and controller side, to kind of pick up the topic and talk about what is really making OpenStack and having it a success in the open networking, in the open networking context. With Bigswitch, I'm happy to hand it over to Carl MacDonald, and Carl is actually very keen in the OpenStack community. He's been working very hard and driving OpenStack standards. And he can give you a bit more technology headlines, insights on how that all fits together. Kyle, thanks very much for stepping in short notice. He just knew it yesterday evening that he was going to speak up. So thank you very much for picking this one up, Kyle.
Awesome, thank you very much. And I'm joined by Syed, who's going to give us the actual technical details. But I thought I would give you a little bit of history. So my name's Kyle MacDonald. I'm an advisor to Bigswitch. I'm also an advisor to Morantis, a number of other companies in the industry. And I was one of the people who was in the room when we started OpenStack about 5.5, almost 6 years ago now. So I thought I would kind of walk us through why you've seen different approaches in networking in OpenStack, and kind of then we can go into a little bit of the success stories. So as we talk about SDN is something that when we really started OpenStack, SDN was almost on a parallel track. People were trying different implementations. We started originally with a world of controllers and network vert being two separate things. There was the Nicira world, and then there was the Bigswitch world. They were kind of both doing interesting stuff, both doing it around SDN, one of them doing it for campus, one of them doing it for really inside data centers. And so as that track sort of exploded, we had in parallel clouds, which we originally had designed in flat Nova network models, moving to much more sophisticated networking. That was the days of quantum when we started looking at plugins and how we did switching and that sort of thing. But the level of complexity in OpenStack clouds, as they started to grow, has made it so that networking is fundamentally one of the most interesting problems and perhaps one of the interesting challenges as you scale your cloud. Just as a function of the number of nodes, just as a function of the management technology you need to use, and then finally, sort of as you start to look at how you source and what the boxes sort of look like. And in order to build a large cloud and have it automate and run the way it's supposed to, you need to look at new sourcing strategies. It means really embracing and understanding what the white box and bright box worlds sort of look like, because that's how you maintain a cost-competitive OpenStack cloud, which for many enterprises is one of the main reasons they're looking at OpenStack, right? It's how do you do things faster and how do you do things more cost-effectively. And so one of the more interesting solutions that sort of come into the market is a solution that has been around for a while, and that is Bigswitch. And so I thought it would be interesting to kind of let you guys hear a bunch of the success stories from Bigswitch, and then at the end we can talk a little bit about some of the challenges that are being fixed. And with that, I think probably the best demonstration is technical. So there you go.
Thanks, Kyle. So let's start with the very basic, like what are the approaches towards networking today? If you look at really from the application perspective, you should see what application is requiring from top-down approach. Like application requires, if there's a, let's say, for example, it's a 3-tier application. So it will require like web tier, database tier, app tier, and you need some network services on top of it. For example, load balancing, firewall. So that's the requirement when you're deploying application. And guess what? How is it gets translated in the network world? So you go to the specific server ports, you are allowing VLANs, then you have to do inter-VLANs, routing, and then you have to go ahead and add firewall policies, ACLs, then you have to maintain those ACLs. So all that is afterthought, okay, now do the plumbing to enable the networking. That's the approach even today. If you do the OpenStack, look at the OpenStack, it's again top-down approach where you have to deploy applications with OpenStack, and then the networking, how you're going to enable the networking. how you're going to automate the networking. So those are all the questions which needs to be answered. So the approach which we have taken around SDN fabric, which is a controller-based fabric, so essentially, you still have the top-down approach where you need to deploy OpenStack and the applications with the Neutron service and how we integrate with the service such that not only you basically enable the virtual networking piece, but also the physical top-of-the-rack switches as well. It's not that when you go ahead and going to deploy the OpenStack application, you're going to open up a trouble ticket to have somebody go ahead and do the plumbing for your physical network. So everything is abstracted to OpenStack so that when you go ahead and deploy any application, you go ahead and that provisioning happens not only on each of the servers for the virtual switches, but also for the top-of-the-rack switches so that it gets automated all the way. What are the benefits? Automation key, physical plus virtual, plus unified view. You need to look at the networking not like, okay, there is a virtual layer of networking, then there is a physical layer of networking. If you are doing troubleshooting, if you need full visibility, logs, everything, you get a unified view. And that's all controller-based view, which has complete view of all your pod with number of top-of-the-rack switches and also your virtual switches which are in each of the servers. Around performance, with the controller-based centralized control plane, you can automate such that you have this distributed logical routing where if two VMs are on the same server, needs to talk to each other, different networks, you don't have to go do hairpinning and go out to the controller, Neutron, some server which is performing this routing functionality for you, and you're going to go ahead and redirect the traffic, and traffic comes back. So all get distributed because of the centralized control plane. From the components perspective, what we are dealing with here on the Neutron side is the networking. So the Neutron plugin is talking to the SDN controller, and then what's the approach on the bare metal switching? So you can leverage the bare metal switching, the class architecture. I believe the session which was having before this under Cumulus, they were also talking about the class architecture where you have these leaf and spines, and you can scale out as needed. And all this is controlled by the centralized controller. So whenever you are doing the integration, you integrate through the BCF Neutron plugin integration with the big cloud fabric. And then when you start with like 2-rack topology, let's say. Here I have an example of 3 racks. As you scale out, your integration is already done over here. So you do not require to do additional development to do this integration when you have 2-rack topology. You start small as you need more compute resources, more storage resources, more network resources. The network resources overall is already being integrated with the controller-based model. So that's how you're going to integrate. As far as simplicity is concerned, with a controller-based approach, you need to build a new rack. You simply go ahead and power up the top of the rack switch, attach it to the management network, and you walk away. The ONI is going to discover, there is a discovery protocol, just like in the server model, you have Pixie boot. In the switch model, you have open network install environment. It's just like a Pixie boot. So it's going to Pixie boot, try to find the operating system. Controller will respond based on the authorization. The only thing you need from the switch is the MAC address of the switch so that you can authorize the switch to get the operating system. That's it. If I look at the steps as far as deploying the Neutron piece in the OpenStack deployment, you go ahead and install the big cloud fabric environment with bare metal switches. Start with 2 racks, 2 dual leaf topology. You can have two top of the rack switches per rack. Bring it up, power them out, They will talk to the controller. Controller will publish them the software. Same software on each and every switch. As you scale out, same software. You don't have to see which software is running on which switch in your entire pod. You install your OpenStack environment. You can use Mirantis, Red Hat, RDO, and then what we provide, either we provide a plugin, which is already available in the distribution, or you run an install script. Then that's when we basically go ahead and integrate with the L2 or L3 Neutron agents. We replace them with our plugin, and your OpenStack Neutron ready to go. Yeah, deployments are customized based on what applications you want to deploy, what's your environment. But as far as Neutron deployment is concerned, you can see not only the virtual switches, but also the top of the rack switches have been automated for you. Any questions so far?
Yeah, as I understand, it's why choose Bigswitch networks instead of Windows, for example? That is the same technology.
So here is the difference. Okay, that's the choice the customer has now.
Okay.
You have the same bare metal switches, whether it could be Dell or any other white box vendor, but you have the choice based on your topology, what type of topology you want. You want an L3 clause, or you want to run something on top of Cumulus operating system. What we are basically providing you is we are simplifying it based on the controller approach. So you are not managing box by box. You're not managing each and every switch. And as we go in this, I'll show you how we are different here. Think about a chassis switch, Catalyst 6500. Pretty much many networking people know Catalyst 550, 6500. So what do you have in a chassis switch? You have supervisors, then you have Ethernet line cards, and then you have a backplane. So these are the three main components for a chassis switch. So we took the same model. What we did, supervisors became the controllers. Then the backplane is the spine switches, which just think about these are interleave switches. They have to connect each other to your racks. And your line cards have become the top of the rack leaf switches. So with this model, the entire pod, which could be as big as 32 leaf switches today, is being handled as one big switch. There is one CLI. You're simply going to go ahead and access the controller, and all these will represent as a line card for that controller. So you are not managing each and every box in this model. It's still leaf spine architecture, the architecture which is the modern architecture here, where you basically scale out as you need to based on your capacity. You start small. As you require more compute resources, you build new racks, and you scale out and attach those to the fabric. Now that was a physical leaf spine architecture with the controller model, centralized controller. We have extended this model with the OpenStack, where we are extending the leaf layer to a virtual leaf layer, meaning that all the virtual switches which are running on the servers will also be viewed as one unified Bigswitch controller view. You log into the controller. Now you don't only see these top of the rack switches, rather you also see all these virtual switches in each of the servers. A complete view for your virtual and physical networking. From the application deployment perspective, the deployment model for any OpenStack user will remain the same. Under the hood, we are basically enabling the virtual switching and the physical networking. But when you go ahead and deploy the application, You basically see, okay, I need three networks. I need one virtual router. I need to introduce load balancer as a service. So all those can get deployed through OpenStack. You do not have to go and do anything manually on the big cloud fabric controller, SDN controller. What we call it a zero-touch fabric, meaning bringing up this fabric, where we are bringing up a new leaf switch, a new spine switch, all are automated. You do not go into the CLI and start configuring these switches. As far as connecting those switches together, all the link detection happens through the centralized view, so that controller can detect exactly what links are connected from one leaf switch to another spine switch to another leaf switch. And with OpenStack, we even configure or detect all the links going to the server side as well. So the links between the leaf and the spine and the links between the leaf and the servers are all detected automatically. You do not have to go and manually do any link aggregation configuration, such as configuring port groups, configuring LSCP, LLDP, or port channels. You do not have to configure them. All of them are auto-configured for you when you're bringing up the fabric. Also, when we are doing any troubleshooting or any visibility you need, it's a fabric-wide visibility. Meaning, if you have any problem from one VM to another VM, and you want to see if the policies or if the configuration is correct, we give you a controller view, that controller has programmed everything correctly or not. Okay, controller has programmed everything correctly, so the two VMs should talk. And now if the traffic is running between them, we can also show you exactly which link in the fabric these two VMs will talk to each other using which of these links. This server link going up to the leaf, from the leaf, which spine. It could be spine 1 or it could be a spine 6. So I can pick any of those spines based off my hashing, and I'll tell you which exactly link it's being used by the two VMs talking to each other. If you build this class fabric, one of the challenges, how you're going to upgrade. What's the upgrade of the physical fabric? What's the upgrade of the virtual fabric? For a physical fabric, we scale today up to like 40 devices. It's 2 controllers, 6 spine switches, and 32 leaf switches. So all of them can be upgraded within 15 minutes. And it's a hitless upgrade, meaning that we cut the fabric in half, we upgrade the first half first, and then we switch and upgrade the other half. During that upgrade window, you do not lose any traffic, you do lose the bandwidth. Bandwidth becomes 50% because half of the fabric is not available for you, but the traffic still get forwarded. As a centralized controller deployment or an architecture with being a centralized controller, you get the benefits of doing centralized, like an entire fabric-wide troubleshooting with something like fabric trace, where we can trace you exactly which links, which leaf switches, which spine switches are being used for basically communicating between the two VMs. And also we provide something which is called fabric analytics. What we do is we collect all the syslogs and provide you a good dashboard telling you exactly what the fabric behavior is. Let's say there was a switch outage last night. You will exactly know what happened last night on the logs perspective. Something got changed. Somebody logged into the box. So all that is provided through a fabric analytic dashboard. And that dashboard not only gives you physical view, rather gives you also the logical view. Any new tenant was created, any new project was created, any new network was created, any VM went down. So all that information is collected and shown in Fabric Analytics. And in some cases, if you want to automate and extract some information or automate some of the features in the big cloud fabric, The entire controller is REST-based architecture, where the CLI and GUI of this fabric controller is using the REST calls. So any new feature which we develop in this fabric architecture, we basically do a REST development first, and then the client or CLI or the GUI is configured later, because they will call the REST to provision or to do any configuration. So if you want to go ahead and automate any of those things, that can be automated very easily. You do not require a good skill set of DevOps to do that development. I was 10 years in Cisco, all CLI, just doing debug REST and seeing what is being called during any configuration. Here you can see the example, show tenant blue. So what REST calls are being made is printed over here when I turn on debug REST. So I was able to make these scripts to automate some of the features very easily. So just to summarize on resiliency part, we are doing all this into a distributed L3 model, where you have distributed routing functionality, you have a distributed floating IP functionality. If you see OpenStack in old days when you have only NOAA network, it was kind of distributed floating IP model, where if one server goes down, the resources will go down, but it's not that the functionality, L3 functionality will go down. Pretty much it has to come back with Neutron as well. So we are providing that distributed functionality as such. From visibility perspective, as I said, VM to VM or virtual machine to a physical machine or VM to any other endpoint, you will have a fabric-wide visibility. You do not need to go box by box and see where the traffic is traversing. With Red Hat, Mirantis, Packstack, we already have deployment procedures. You go ahead and deploy your OpenStack. You go ahead and deploy your big cloud fabric as such, and then run the script to integrate. Anybody heard about Chaos Monkey? Okay, so there are few people who knows about Chaos Monkey. This is a term used by Netflix. What they do is, this is a testing model where you are doing testing with introducing failures in your network and checking out how resilient is your network. We did this with our total scale solution, which is 32 leaf switches, 6 spine switches, running Mirantis OpenStack on top of it. And we started doing these failures where we are failing the switch, we are failing a link, we are failing controllers. So there were like 640 component failures in 30 minutes, and then we are running application on top of it to see what's the performance impact. So essentially, the performance impact was negligible on the fabric. That includes spine switch too, yeah. Because we had the 6 spine switches, so we are failing a spine switch at the same time. So the whole architecture was made ground up to handle failure scenarios. Link failures, spine failures, leaf failures, even both controller failures. Even if your both controllers fail, the traffic still forwards the traffic without any disruption, but you cannot learn any new endpoint. You cannot deploy a VM. So this is like more graphical views of things which you see without or with Big Cloud Fabric. If you have to do any L3, basically to east-west traffic, it will go through a Neutron L3 agent, which is somewhere in the controller server cluster, 3 servers, 4 servers, or whatever. So it's going to do a hairpinning and then go the traffic. With Big Cloud Fabric unified P plus V, whenever the traffic goes, Switchlight is going to go ahead and do that L3 routing for it on the same server, so that you do not have to do any hairpinning to go to the next network. For floating IP, similar concept. We do the floating IP translation on the switch light itself. So no hairpinning as such. Some of the big cloud fabric benefits which we have in the controller itself, we have exposed it to the OpenStack. For example, the visibility, the fabric trace, that has been exposed to the OpenStack dashboard. So you can go ahead and run these reachability tests for any two VMs in a project to see if those VMs can talk to each other or not. And it also gives the details of which top of the rack switch, which spine switch, and which destination top of the rack switch it has used to connect with each other. You can see that all the details are being provided here. If you are doing any OpenStack security groups, just to provide some level of micro-segmentation, we have the visibility in the big cloud fabric. So the network guy will know that the traffic is being blocked because of the security groups. Even though the security groups are local to the Linux within the host, we are not doing security groups within the vSwitch, but we have the visibility to tell you right away in the big cloud fabric that what's happening at the end. And even our trace, packet trace, will tell that the traffic is being blocked because of the security groups. This is the trace, the entire trace of the policies, how they are going through each of the vSwitch and to the destination. We also provide some templates. If you're deploying a 3-tier app, you have to create 3 networks, then you have to create a project router, then you have to add these 3 networks to the project router. So all that we can expose a template. You can use that template to deploy a 3-tier network on the dashboard, and we can deploy that for you. So just ease of configuration, because there could be still human errors, because not everybody is network savvy as such, and especially for a project user, if he needs to deploy a 3-tier app, he has to go through a number of steps to achieve that. Okay. So just to summarize, with SDN Fabric, you get automation. Especially with P plus V, you have a unified view of the network, physical network and virtual network. And performance, if you see doing L3 agent on the local host, you are having a distributed routing, you have a distributed floating IP, the NAT functionality, and no hairpinning. So the performance-wise, this basically scales much better than a model where the traffic has to hairpin to any server and then go out or coming in. Lastly, I'll finish off by, if you want to test it out, you can do a test drive by going to labs.bigswitch.com. We have modules there. You can run on your own lab. It's a guided lab with a guided lab guide. You can follow the lab guide and do some test yourself with P plus V solution, and you can see the benefits right away. Thank you. I'm here for questions if you want to ask any question. Yes, sir.
Do you have integration with data center operating systems like Terraform, Mesos, or Mesosphere, or Kubernetes?
So if you want to extract some of the information, like the way we have exposed it to OpenStack dashboard, you can customize through calling our REST APIs. Because everything is REST-based API, so the architecture is there where we formally do not integrate with certain systems, but you can customize and you can do the calls and you can add custom dashboard for Bigswitch. Any other question? I saw one more hand. Yeah? You want to add something? Cool. Thank you.
Thank you.
Good job.